All right, now we're going to take a look at some solving and some simplifying involving imaginary numbers. Nothing too drastic. Again, it just adds, one additional layer onto our solving process. So when we get involved with imaginary values or imaginary numbers, a lot of times the strategy we're going to use to solve for us will be the inverse operation strategy. So you can see here in our first example, we're going to solve. And I see I just have x squared. I don't have an x. So that's kind of like a tipping point or a look for me that tells me, hey, I'm going to use inverse operations. I'm going to subtract x squared to both sides to get an x squared. Add 4. That gives me negative 25. So again, up to this point, we used to say that, all right, if I take the square root of both sides, square root of negative is no real solutions. But what we have now is we have the ability to calculate the imaginary solutions. So in doing so, like I said, I'm going to take the square root of both sides. That's going to leave me with x equals plus or minus 5i. So basically, this negative sign here just becomes an imaginary value, or the I. Now, sometimes we might have an answer that just has a term with an I. So we have something different here in number 2. So in number 2, what we see is we have parentheses being squared. And anytime I have parentheses being squared, I'm going to try to isolate those parentheses. So my first step is going to be to divide both sides by negative 2. It's going to give me x minus 1 squared equals negative 18. Now my next step is to actually take the square root of both sides. Because again, I have the parentheses being squared. So now that's going to leave me with x minus 1 equals, whenever I simplify this, I have to realize I basically have 3 parts, if you would. I would have the square root of 9, the square root of negative 1, and the square root of 2. That's what I would actually be able to break this down. Why would I break it down into 9, 1, and 2? Because 9 is 3, square root of negative 1 is I, square root of 2 is already simplified. So the square root of negative 18 is actually able to be written as 3i square root of 2. Now I'm not done yet, because keep in mind I have to try to get the variable isolated or by itself. So I'm going to add 1 to both sides, and when I do so, those are not like terms. So I can't combine the 1 and the 3. I'd have to write it as 1 plus or minus, I almost forgot, plus or minus 3i square root of 2. Yeah, one of the most important things is that plus or minus when we take an even root, and I almost forgot it there. So this is some of the solving stuff. And we got into a little bit of simplifying there. There are some other simplifying type questions that you might come across also. And these type of problems are nice because it just takes us back to basically combining like terms. So you see that we have 2 additional questions, like so. And what we have actually is a complex number plus another complex number. That's a complex number, and that's a complex number. We're going to talk a little bit more about complex numbers in another presentation, but for us right now, when we have to simplify this, all that we're going to do is we're going to go ahead and combine our like terms. So I see I have a 6 and a 5 gives me 11, a 4i and a negative I gives me a plus 3i. I just combine my like terms. Now, honestly, one mistake I see students make sometimes is the fact that since they see parentheses, they want to try to go ahead and multiply those 2 expressions together. And since the operation in between here is addition, that's telling us why we're combining our like terms. We're not multiplying there. If I take a look at the second example, very similar. I see an expression, but now I'm minus another expression. So my recommendation here is let's begin by distributing. All right, so that way we don't make any errors. So over here, this is going to stay the same. I'm going to distribute the negative to be minus 1 plus 2i. I combine my like terms. 3 minus 1 is 2. Negative 5i and 2i, negative 3i. And that's an example of what we'd be looking for when we simplify with just addition or subtraction.